All right, hello everyone and welcome. Let's think of this as our pre-exam game plan for one of the most important topics you're going to face in SPM Chemistry, Group 17, the halogens. We are going to absolutely crack the code on how these elements work and, more importantly, how you can lock in those marks.
Okay, before we properly dive in, I gotta give you my #1 tip for acing your exams. You have to practice. So after we go through all this, seriously, go test yourself. You can find tons of past year questions over at www.mcqspm.com, or just whip out your phone and scan the QR code on the screen. It's truly the best way to make sure all this information actually sticks.
Right then, let's get into it. First things first, who exactly are these halogens, and why do they get their own special group in the periodic table? Let's find out.
So, meets the main players of Group 17. We're mostly going to focus on fluorine, chlorine, bromine, and iodine. Now, each one has its own kind of personality, but as we're about to see, they all share a really crucial family secret. So, officially, the textbook definition says halogens are highly reactive nonmetal elements, and their address is super simple. You'll always find them in Group 17. That's the second column from the right on the periodic table. Easy to spot.
So what is that secret code I was talking about? The thing that ties them all together? It's this number, 7. Every single halogen atom has 7 valence electrons. And remember, valence is just a fancy word for the outermost shell. Having 7 electrons there, well, that's the key to understanding literally everything about how they behave. Here's the whole family. Now, this is a super important exam point. In nature, halogens are never, ever alone. They always have a buddy. We say they exist as diatomic molecules. Di just means 2. So you're always going to find them as F2, Cl2, you get the idea. Okay, now for the part that makes SPM questions so much easier to handle. The halogens follow these really predictable patterns, or trends, as you move down the group. And if you understand these trends, you can pretty much predict the answers. Let's kick things off with their physical properties.
And look at this, it perfectly shows one of the clearest trends. Up at the top, you've got chlorine, which is a greenish-yellow gas. Go down one step to bromine, and suddenly it's a reddish-brown liquid. Go down again to iodine, and it becomes a purplish-black solid. You see that pattern? Gas to liquid to solid. And their colors get darker and deeper as you go down, too.
So this leads us right into a classic exam question. We can see that the state changes, which obviously means the melting and boiling points are going up, but the real question is always why?
The answer, and this is a classic exam topic you might see in a question like MRS 2011-A23, is all about the forces of attraction between the molecules. We call these intermolecular forces.
Let's break this down. As you go down the group, the atoms just get bigger. They've got more electrons, more shells. So think of these bigger atoms as having a stronger, kind of temporary magnetic pull on their neighbors. This pull is called the van der Waals force. Now, stronger forces mean you need more energy, more heat, to pull those molecules apart and turn them into a gas. And that's exactly why iodine's boiling point is so much higher than fluorine's.
Okay, theory's great, but let's be honest, marks are won by applying it. So let's take a look at how we can use these ideas to solve some actual SPM questions.
Okay, here's a pretty typical question. They give you these mystery elements with proton numbers. R is 9 and V is 17, and they ask what they have in common. What's your first move? Now, let me tell you about a super common mistake students make here. They see letters like R and V instead of actual element names, and they just panic. But don't forget the golden rule. That proton number is your key. It unlocks the electron arrangement, and that's the information you really need. So the trick is to just follow the steps. First, you write out the electron arrangement. For R, with 9 electrons, it's 2.7. For V, with 17 electrons, it's 2.8.7. And boom, there it is. They both end with a 7. That means they both have 7 valence electrons, which tells you they're in the same family. Group 17. Simple as that.
Let's tackle another one, this time on chemical properties. Why does the reactivity of the halogens actually get weaker as you go down the group?
Now, you've got to notice the contrast here. This trend is the complete opposite of the boiling points. Boiling points go up, but reactivity goes down. Why? Well, it's because reactivity for a halogen isn't about how well it sticks to its neighbors, it's all about how badly it wants to grab one more electron to get a full outer shell.
Here's the logic. As you go down the group, the atoms get bigger. Imagine the nucleus is like a magnet in the very center. For a small atom, like fluorine, that outer shell is really close, so the magnet's pull is super strong. It can easily snatch an electron. But for a big atom, like iodine, the outer shell is much, much farther away. The nucleus's pull gets way weaker over that distance, which makes it harder to attract that final electron. And that means it's less reactive.
So why does any of this matter? Because halogens aren't just stuck in your textbook. They are literally all around us, doing really important jobs. And of course, this is a favorite area for examiners to ask questions about.
Let's compare two of the most famous family members. As we see in questions like MRS 2019-A35, chlorine is an awesome disinfectant. We use it to kill bacteria in swimming pools and our drinking water. Then you have its cousin, iodine. It's also a killer, but we use it as an antiseptic to clean cuts and wounds, a fact that's been tested in questions like JOH 2024-B7. See? Same family, but slightly different jobs.
To sum up their key reactions for your exam, just remember these two simple rules. If you mix a halogen with water, you're going to get an acidic solution. And if you react a halogen with a metal, like iron, you'll form a type of salt we call a metal halide.
So, there you have it. Your master strategy for Group 17 is basically a 3-step plan. 1. Know the trends, both physical and chemical. 2. Don't just memorize them, you have to understand why they happen. It's all about atomic size and forces. And 3. Connect all that knowledge to their real-world uses.
So, I'll leave you with a final challenge just to make sure all this knowledge is locked in. Based on everything we've talked about, which halogen do you think is the most reactive, the most powerful of them all? And what's the simple reason why? If you can answer that, you've totally got this. Good luck with your revision, and I'll see you in the next explainer.